Hello everybody. As you have already heard, my name is Aelita Shaykhutdinova. I hope you see and hear me well. I will tell you about pretty simple but still interesting usage of data science, computer vision in particular in industry. We will talk about implementation of plants weighting based on camera footage. But firstly, I will shortly tell you about the company where this project was developed. So I'm working at your company, and this is actually a group of two companies, Data Lab and Dialog Systems, and I'm part of the Data Lab. This company is a studio for developing solutions based on computer vision and big data analysis. And the Dialog System focuses on developing chatbots, voice skills, and automation of contact centers. Also, in Eura, we have two main products, Vision Hub and OneDash. Vision Hub was developed in Data Lab, and this is a machine learning model marketplace with the ability to quickly integrate them into business processes and projects. And OneDash is a tool for chatbot analytics. Let's return to the discussion of the project. The task was pretty straightforward. We needed to predict mass of the plants from images. You may wonder where and why it may be useful. It will be used in a farm company. A farm creates vertical farms, and main goal of their work is to produce products such as vegetables, berries, and herbs in an urban environment, so that the production is really close to the customers. Also, they help to answer different questions, such as how to optimize energy costs. And you can do this by choosing a place for a vertical farm with a favorable electricity cost, or use alternative sources of electricity, or reduce energy consumption. Farm engineers and agronomists continuously conduct experiments with light, test various types of lamps, determine the optimal duration and mode of additional illumination for plants, and they find solutions that increase the energy efficiency of the green production. And they do this to make the cost of their vegetables and herbs and berries are minimal. Talking about importance of the project. Firstly, as I have already said, vertical farms are great because they're close to the customers and reduce energy consumption and the cost of the plants. Also, they utilize less water and less fertilizers. They also don't use pesticide and save energy. Also, logistic costs are minimal because there is no need to transport plants. Also, they reduce the risk of human factor and labor costs. Secondly, talking about the solution that I am presenting you, the solution of automatic plants weighting, it will reduce the cost of the products grown on vertical farms. Their cost depends on many parameters such as seeds, fertilizers, electricity cost, and of course, employee salary. And the last one can be optimized only by reducing labor cost of employees, by automating production processes and excluding expensive specialists from the staff. And automation systems significantly reduce participation of people in the production cycle. And the cloud platform that a farm company is developing helps to avoid involving expensive specialists in the staff, such as engineers, agronomists, plant protection specialists, and many others. Because their system already contains ready-made so-called recipes for growing the plants. In addition, their system provides tools for monitoring the microclimate, such as CO2 level, temperature, humidity, power supply, and production processes. But visual control of plants until recently remained the responsibility of farm employees, and they had to physically walk around the huge farms and inspect thousands of meters of planting space. And the solution that I am presenting is about to change this. So let's talk about data collection. Data collection is one of the most important steps in our data science project, and this one is not an exception. And in this work, the data collection started with the question of camera choice and camera positioning. Camera position should be constant at all shelves and fixed, since it is important in order to estimate the size of the plants and therefore their weights. Also, cameras should be water resistant and be able to capture as more plants as possible on the shelf. And together with a farm company, we agreed on using Xiaomi YI action camera, as you can see on the picture. Then it was needed to collect weight data somehow. The problem here is that in order to weight a plant, it should be removed from the shelf and from the ground. So we do not have weight data of plants that are particularly on the picture, because it cannot be returned back without consequences, meaning its weight may change dramatically after we take it from the shelf and from the ground and return, or sometimes we even cannot return it back. Therefore, in parallel with collecting photos from identical shelves without cameras, so-called control plants were weighted every 3 days, and thus we obtained data of plants' weight, not from the plants that are in the picture, but from the identical plants with the same microclimate parameters, nutrition and lighting, and on the same day of growth day. And here are the examples of the resulted data. We decided to use 2 cameras to capture 2 views of each shelf. One is so-called front view, and another is top view. This is Romana salad, and we decided to work for MVP project only with one culture, Romana salad, and the photos were collected every minute for 30 days, and this is because this is an approximate growth cycle for this culture. Also, we have data not only from one shelf, but from 4 different shelves with different light parameters. As you can see on the slide, we used segmentation by green color because we wanted to estimate area of the plants, because this is the one of the most valuable information that we can get from pictures. You may thought that then we just can estimate weight of the whole shelf just by calculating the dependence of area and weight. But the problem that not all plants are visible on the picture, as you can see, and as plants are getting bigger, less plants are visible in the picture. For example, in this picture, you cannot see the first row really clearly, and taking this information into account, we restricted our vision to the first 3 plants from front view. So I will show these 3 plants from this kind of pictures, and to the 9 plants from top view, this one. Because as they're getting bigger, you cannot fully absorb this one and this one. But we still need to get some contour or region of interest of each plant to correctly estimate their area. And here comes the question about labeling. At first we thought to just create instant segmentation masks, meaning to segment each plant like this, but the problem that this process is really time consuming and expensive. Also, we was not sure if the model will be capable to learn if the given leaf corresponds to a particular plant or not another, because even for human, it's sometimes really hard to understand if this particular leaf corresponds to this plant and not this. Therefore, we decided to train a detection model rather than segmentation. And for this, we use a faster RCNN and achieved 0.98 of mean average precision. Then here, this is the visualization of model prediction of the detection model. Let's view the whole process of the preparing data. Firstly, we need to calculate average plant weight at each day. This information we get from the data that a farm company collected for us. As I have already said, each 3 days they weight a plant from a data called shelf. Also, we collect another statistics like maximum and minimal weight at each day because it may be useful later. Then we detect plants, get bounding box of each plant, find green area inside each bounding box, then calculate average area of a plant at each day, because from each day we have several amount of plants, 9, and we calculate average area of their at each day. And then we calculate ground truth weight of each plant using this equation. Simply speaking, the greater the area of a plant, the greater its weight. And also important that the ground truth weight would not be super heavy, because all plants that we have in our pictures are under normal conditions, and therefore we then also check that they are not greater than the maximum history values of weight at this day, or not super small. On this slide, you can see the dependence of plants' weight and area from growth day. The data from some days were missing, and therefore you can see spaces on the right plot because camera accidentally stopped recording or some data was missing. And also from the right plot, you can see that the dependence of area is not so clean as we expected. Hence, we decided to utilize some other features for weight prediction. And to choose the features, we trained several linear regression models with different feature set, and the one that utilizes all of the features, which are top area, front area, light percentage, and growth day, showed the smallest error rate, and therefore we decided to use the model that utilizes all feature. Then we created a Telegram bot in order to show the farm company our solution, and so they can see, given a particular picture, what our model outputs. In our Telegram bot, you should send 2 pictures, one front view and one top view from one shelf. Also enter light percentage, the 4 available values, 40, 60, 80, and 100. And the Telegram bot return predicted weight for 9 mostly visible plants from the top view, and the picture. The model also number each plant. And also, as we showed, as feature selection showed that day is a valuable feature for predicting plants' weight, we trained a model to predict a day from a photo. Also return this predicted day and some history values of plants' weight at that day, average value, weight value. Also during testing, we somehow fine-tuned our model, and this plot showed the result, how the resulted model predicts weight for one plant over the days. And the model achieved the error rates presented on the slide. Mean squared error of 0.001 0.09 and mean absolute error of 0.2. Let's one more time review the whole pipeline of our so-called model. Firstly, we need to get top view and front view photos and light type, then predict a growth day of a shelf from a top view image. Why top view? Because we tried several models for predicting a growth day, and one that uses top view image demonstrated smaller error rates. Then we detect plants. Then we calculate green area of 9 top plants and average of 3 front plants. As you have seen on pictures, it is hard to make correspondence between each plant from front and top view because not all plants are visible. Therefore, we use front view image as an extra feature. Just calculate average of visible area. Calculate average of area of visible plants and use this as an extra feature for each 9 plant from the top view. Then we predict weights using all the gathered information from previous steps. And lastly, we compare the predicted weight with history values. The history values are the same that a farm company gave us in order to train the model. And idea that if the weight is greatly smaller than the history value, then systems should somehow make an alert signal in order to change the microclimate, in order to make the plants more healthy and more heavy. And actually, to minimize the amount of employees on the farm even more, a farm company wants to utilize drones, and the idea that drone will fly over the shelves and make photos to send to our model. And if there are significant difference between the predicted and history weight values, as I have already said, the system will make some alert signal, and the microclimate parameters would change because all these things are automated in farms, and there's a system that can automatically predict what light parameters is better for the given situation. But as you can see on this slide, for drone, it is hard to fly inside the shelf, and it is hard because the width between shelf is not so big. It is hard to make top view photo. Therefore, we, as a next iteration, as an improvement of our model, we decided to try to make a model that uses information only from front view photo. This is just a video visualization how our system altogether should work. Also, when we use photos, only front view photos, we will have only 3 plants from each image, and therefore number of training example decreases 3 times compared with previous case. And as I have already said, the data about plants weight was collected every 3 days, or sometimes even every 4 days. And therefore, we could increase number of training samples by interpolating weight values, so that we will now have training values not from every 3 days, but every 2 or every day, and also interpolate the plant area values. This is the result of the model that uses only front view pictures, and the error rates are demonstrated on the slide, and they're a little bit higher than the previous model. So as a future work, we would like to use data collected also from drone, because now we only use data collected from fixed cameras, and we expecting that there may be some more noisy data, because maybe they would not be so fixed like we used to. Also, on the farms, they will not only be drones, but still some humans, and also some employees will may want to make a photo on their maybe phone or tablet and send it to our model to get some prediction. Therefore, we would like to use different kind of data in order to our model to be more stable. Also, we would like to try different cultures, as I have already said. We used only Romana salad, and we would like to also try to different maybe berries or herbs. Also, it will be great if we automate data collection and training pipeline. And of course, we can improve current solution, because now we use small amount of information from one picture. We use only predict weight for only 3 plants from the front view. Maybe we can improve the process, the way how we find the contours of each plant, or something else. So thank you for your attention. I would be happy to answer your question or discuss the demonstrated work.
Hey, Aelita, thank you so much for the lecture. That was very interesting how you can get to know something just from the photo. And I have a question regarding your regarding connection of this investigation of yours and the previous one mentioned in your bio, the one about the body parts of human. Is it like done this kind of the same way as weight of plants?
Not really. Segmentation by parts, meaning that you know that there are Instagram masks that may segment, meaning find a contour of a person and maybe change the background. And or in Zoom meetings, I thought many of you have seen this. And there are models that not only can segment the whole person, but its part like hands or face or clothing. And
yeah, that's great. Actually, I think we have such a thing also in the recognition of the screen. And when you try to add green screen here, for example, on the StreamYard, the platform we're using for this broadcasting, it's really bad one. I can demonstrate how it looks like. Yeah, it looks like that. You can see it as a ghost. Yeah, and here recognition works really badly.
yeah, this is because you do not have a background, green background.
Oh, we actually tried that with Anna, and she had a green background, but it didn't help anyway. I mean, it helped a bit, like a little bit, but the recognition still was like not great, and that's why this was the reason why we got rid of idea of using the backgrounds of our conference, like for the speakers and for us. So yeah, this was the reason. Yeah, we have a comment. So much information. I didn't catch what is the target of this CV technology. Oh, maybe you can give an overview.
Yeah, the idea that nowadays in the iFarm company, there are many employees that are going through the farm, through the shelves, and They need to, by their eyes, look at the plants and see if they're okay, if they're not, if they're healthy, if they're growing as expected. So they're as big as expected on maybe second day of their growth. And because it is really expensive to have a lot of employees, they decided to use a drone that will fly over the farm, collect photos, and our model will predict the weight of the system, and maybe some other model will predict if the plant is healthy. Not predict if the plants have some diseases and other things. And there is an system that automates microclimate of the plants, change the light, or maybe will tell that another employees that they should change the nutrition for these plants because they're not healthy. Yeah, I think it. You get some point.
Yeah, got it. Thank you so much, and thank you for the question. I have a question. If you ever counted how much money did you save using this technology on the labor and so on? I mean, the physical labor, on hiring less employees and so on.
Personally, I did not do this because I do not know how the labor of employee on the farm costs. Yeah, and actually this system is not really is not already working. Like this was MVP project, so we need to improve it before putting it into industry.
Oh, got it. Okay. Are you planning to do that soon?
Yeah, while we were doing this project, they were not drawn yet, and now with another company, they have conducted experiments how the drone fly. You saw the video, and now we can combine the work that were done using the drone and our work, and see what's will come out of that.
Got it. Thank you so much for the answer.